Good morning, students. In the last class, we studied about the structure of amine, ammonia derivatives. Those are called as amines, and what are the classification, then ammonotypes. Okay. So in today's class, we are going to discuss about preparation of amines. Okay. Is preparation of amines. Okay. So this preparation of amines is taking place by 6 different steps. Okay. Different reactants are there, different reactant species are there. By using that, we will discuss. Okay. So first one is reduction of nitrobenzene. First one is reduction of nitrobenzene. Next, reduction of nitrites. Okay. And third one is reduction of amines. Reduction of amines. Next, monolysis of alkyl halides. Okay. Next, Gabriel phthalimide reaction. Gabriel phthalimide synthesis. Synthesis. Last one is Hoffman bromide reaction. Okay, these are the 4 different types of reaction from which we are going to prepare these amines. Okay, so one is reduction of nitrobenzene, reduction of nitrites, reduction of amides, ammonolysis of alkyl halides, Gabriel phthalimide synthesis, and this Hoffman bromide reaction. So in this is very important. So whatever it is, students, neighborhood reactions like Gabriel, Hoffman, Schwartz, Nicholson, like neighborhood reactions are there. All the neighborhood reactions are very important in this organic chemistry. Understand? Neighborhood reactions. For example, in the last year you studied for alkyl halides, you studied post reaction, critic reaction, acidic reaction, right? So like such type of neighborhood reactions are very important in this organic chemistry chapter. Okay. So in the amines, we have 6 different types of preparation of this. This is not that much important, but the neighborhood reactions are important. This is very important for 2 marks. Understand? So we will discuss one by one. First one is reduction of nitrobenzene. Okay. So students, this reduction of nitrobenzene is, this is the structure. This is nitrobenzene. So reduction means what? Either removal of oxygen or addition of hydrogen. That is called reduction. So here, reduction of hydrogen takes place in presence of palladium and ethanol as a pH. Okay, so palladium emitted and platinum emitted. Okay, so addition of hydrogen takes place in presence of the catalyst palladium with the and also solvent ethanol. Then here it forms NH2. So this is the functional group of amine. Correct? So this is amine. This one is nitrobenzene. Okay, students. Next, another one is there same This nitrobenzene undergoes reduction in presence of metal under acid, either SnRHCl or FeRHCl. Okay, then it undergoes reduction only, that is addition of H2. Then you form NH2. So instead of writing this circle inside this, you may write double bond also, students. That depends on you. Either you write this or you simply write like this. Okay? And remember, in the product side and reactant side, write the double bond in the same position. Okay? So this is the reaction. So for this, students, this is nitrobenzene. And this one is aniline or benzene. Okay, so by seeing this, you have to write the explanation. Okay, so what happens here? So nitrobenzene. So this is a reduction reaction, correct? This nitrobenzene is reduced to what? This product, that is aniline. Nitrobenzene is reduced to aniline when H2 gas is passed in presence of palladium as a catalyst. Okay, using ethanol as solvent. If you write this reaction with the name and this much explanation, you will get 2 marks in the examination. This explanation and this reaction is important. What happens? By seeing the reaction, you may easily see. Here, nitrobenzene is reduced to aniline. When this hydrogen is passed in presence of this palladium catalyst in the ethanol solvent. Okay? Everything is in the reaction. That is used to written in the words. Understand? Here what you are going to write? Nitrobenzene is reduced to aniline in presence of a metal under metal as a catalyst, either Sn or Fe in presence of the acids. Understand? You may write here nitrobenzene is reduced to aniline when H2 is passed in presence of metal and acid. Okay, so this is the only unique reaction is there. There is no replacement. You may directly write it sequence. Understand? This is nitrobenzene and aniline. It has 2 steps. So this reduction of nitrobenzene has 2, A and B. Understand? In A, hydrogen, palladium, ethanol is the reaction conditions. Here Sn, NCl or FeHCl is the reaction condition. Okay? So 1 minute. Okay. So the next reaction is reduction of nitriles. Okay, students. So this reduction of nitriles means Cl compounds. Nitriles means Cl. Cyano compounds are called as nitriles. Okay. So listen here. RCl compound is there. And you may write it as C triple bond N. So here triple bond is there, students. To convert triple bond to single bond, we may have hydrogen. Correct? So here reaction takes place. Reduction means addition of hydrogen. Then it forms R. Here C is there. That is CH2. Single bond NH2. Understand? What happens here? Only at this triple bond is converted to single bond by the addition of H2 molecule. So what are the reaction condition here? To add this, either lithium aluminum hydride is used, followed by hydrolysis. Okay? Lithium aluminum hydride followed by hydrolysis forms this amine. So here students, this is nitriles, or you may say alkyl nitriles. This is amines. Alkyl nitriles, this one is amines. So here you write. So listen, one alkyl nitriles undergo reduction. This one undergoes reduction when with or in presence of what? Lithium aluminum hydride followed by what it is? Hydrolysis. Followed by hydrolysis gives amines. Okay, students, this is the general reaction. When alkyl nitriles undergoes reduction in presence of lithium aluminum hydride followed by hydrolysis gives amines. Okay, so I will write one simple example. So this R group is replaced by CH3. CH3 is there, correct? C triple bond N. Okay, so alkyl nitride means this one is methyl nitride. Right here, methyl nitride. So reaction condition is same. That is first one lithium aluminum hydride followed by hydrolysis. Right? Everything remains same. Only this R group is replaced by CH3. So that's why alkyl is replaced by methyl. Correct? So then here this is CH3, CH2, NH2. Correct? Here two carbon atom is there. Then this is ethane. Lastly is replaced by amine. That is ethane amine. So then students, you have to write the words. You have to explain this reaction. Words or explanation means when here in the place of alkyl nitride you have to take methyl nitride. When methyl nitride undergo what? Undergo reduction. Okay? In presence of this lithium aluminum hydride. Okay? Followed by formed here is ethanamide. Gives ethanamide. Okay, so this is the example. How this is the general reaction. This is one example. Take this one as example. Okay, students. So instead of this R group, here is same reaction is taking place here only. We don't bother with this R group. R group may be alkyl, aryl. It may be consists of 100 number of carbon atoms. We don't bother about the R group. It may consist of 100 number of carbon atoms also. Then the reaction is taking place at this CN only. That is reduction of nitriles. Understand? This is the second reaction. Understood? Next one is system is for this reduction of nitriles. Another one is there, that is RC triple bond N compounds reduced in presence of hydrogen and nickel as the catalyst. By passing hydrogen and nickel as a catalyst by using ethanol as a solvent. This is another reaction. Okay. Then also what happens? It gives RCH2 single bond NH. RCH2 single bond NH. This is also another reaction which is given in NCERT. Okay. So instead of this R, you may take CH3. So if you want to write the explanation, students, alkyl nitrile is reduced to amine when hydrogen gas is passed in presence of nickel as a catalyst and ethanol as a solvent. So if you want to write, this one is alkyl nitrile, means alkyl nitrile is reduced to amines. Alkyl nitrile is reduced to amine when H2 gas is passed in presence of nickel as a catalyst and ethanol as solvent. Okay, so by replacing this as students, I'll write the reaction here. You simply write CH3, CH2, C triple bond L. This is the reactant species I am giving. You complete the reaction and write the explanation. Okay, here this is 1, 2. Two carbon atoms are there, then it is ethyl nitrile. Ethyl nitrile, like alkyl nitrile, this one is ethyl nitrile. You will get the answer propanamide. Okay, you just complete the reaction and write the explanation as it is. I wrote here, so wrote here by replacing alkyl nitrate by the respective nitrate here and this amine by the respective product. Understand? So this is about reduction of nitrate. Next we will discuss reduction of amines. Okay? Reduction of amines. next one is reduction of this amides. So amides means students that is CONH2 compounds. Amide group means, and right here listen, are C double bond O NH2. So this group is called as amide group, that is CONH2 group. Okay, so this group is called as amide group. So when this amide group is treated with same lithium aluminum hydride followed by hydrolysis. Okay, lithium aluminum hydride followed by this hydrolysis. Then what happens? You directly say this is R. Here it is CH2 NH2. Correct? Here the removal of oxygen and hydrogen takes place. So if you write here plus H2. Understand? So here reduction takes place. Reduction of amide means this is the amide group. C double bond O is reduced to what? CH. Removal of oxygen, addition of hydrogen. So this is alkyl amide. Okay, you may say alkane amide, ethanamide, alkyl amide. So this one is alkane amide. Right instead of this. Alkane amide. Okay, students. So here what happens? When this amide is reduced to amine, when it is reacts with lithium aluminum hydride followed by hydrolysis. Understand? So you have to write here, this is amide means you consider alkane amide is reduced to alkane amide. Amide is reduced to amine. Am I right? Alkane amide, that depends upon what? What is the group you are taken here? If it is aryl group, then it is benzene amide or aryl amide. Okay? You simply take, okay, alkane amide is reduced to alkane amide to amide. When it reacts in presence of, sorry, not reacts, it is to alkane amide in presence of lithium aluminum hydride followed by what? Hydrolysis. Followed by hydrolysis. Okay? So students, instead of this R, you take and write this C group like this. C double bond O NH2. This is the amide group here. Whatever may be the R group, we don't bother. Okay? So here you take C double bond O, NH2 is the reactant. If we take R group as CH2, CH3. Okay? And we will take it as CH3 also. We don't bother about R group, we are considering only the function group. Then here reactive species, that is lithium aluminum hydride followed by H2. So what is the product formed here? Here CONH2 changes to what? The CH2NH. Simply write CH2 NH2. Here it is the R group. The respective R group here is CH, CH3, CH3. Only R group is replaced. Remaining is same. Correct? Here what happens? C double two. I'll write here. Which one is changes? C double bond O changes here to CH2. Only that change takes place. Okay. So then this is students 1, 2, 3 is there. You may take it as isopropylamide. The second carbon atom CONH2 group is attached. So isopropylamide you may say. Okay. Next, are you messages? 1, 2, 3 means 2. 1, 2, 3 you consider means that is 2 methyl. 1, 2, 3 means propylamide. Okay, you may say whatever the way you want. So this is the common name isopropylamide. So this one is 1, 2, 3. In second position methyl group is there. So 2 methyl. 1, 2, 3 carbon atom means propylamide. Okay, so 2 methyl propylamide is the correct answer. This is what reduction of amines. So next we will discuss ammonolysis. Okay, so what is this ammonolysis? Means ammonolysis of alkyl halide acid. Okay, this complete reaction. So I will take this first. Addition of alkyl halides. A reaction between, not addition, okay. Reaction of alkyl halides with ammonia in a sealed tube at 370 Kelvin in presence of ethanolic solutions. Ethanolic solvent is called as ammonolysis. Right? It's called as, so students, they didn't ask what is ammonolysis. So you remember one thing, when this reaction of alkyl halides with ammonia in a sealed tube at 370 Kelvin in presence of ethanolic solvent. Okay, so I write here nitrogen is there with a 2 lone pair electron, this NH3. Correct? Plus RX. This alkyl halide reacts with what? Ammonia. Okay, so this ammonia are this hydrogen, ammonia they written as what? Like this. Right? So this reacts with this reacts with this. So then what happens? Here one hydrogen is replaced by R, that is N, R you can say NH2R. Correct? NH2R plus H. This is primary amine. Next, consider this primary amine again reacts with RX compound in presence of ethanolic solution. I already wrote. Then what happens? Again this hydrogen reacts with X and this R is attached. Then it becomes NH2 plus H. Understand? Next, consider this one is secondary amine. Next, if this NH2 N plus X minus. Okay students, So this overall reaction is written as, so listen, this ammonia NH3 reacts with how many molecules of what? 1, 2, 3, 4. So this is 4 RX type of compound gives rise to R4 N plus X minus. This is quaternary ammonia. So this is a step by step reaction. First it changes to primary, secondary, tertiary, and quaternary. Understand? This process is called as what? Ammonolysis. So this whole process is taking place in presence of what? Ethanolic solution. So students, in the NEET examination, they are going to ask how many moles of alkyl halide required to convert ammonia to tertiary amine. So ammonia to tertiary amine we want means how many moles of RX we get? 1, 2, 3. Okay. How many moles of RX required to convert the primary ammonia to secondary amine? Just we require only 2. Okay. For quaternary means 1, 2, 3, 4. This is the question they are going to ask in the NEET examination. Like this, about this ammonolysis means they directly ask how many moles of RX required. Or they may ask directly CH3 X levels. So there are these students CH3 4 times N plus Cl minus as well. Okay. So how many moles of CH3 Cl required to form this type of complex? From this you are going to know whether it is primary, secondary and tertiary. Then you will understand how many moles of that respective alkyl halide requires. Okay. So this is ammonolysis of alkyl halides. The next one is Gabriel halamine synthesis. This one is very big reaction. Takes place in so many steps. Amide means which bond, which group is there? Amide. Just now I explained here reduction of amide. Amide means which group can present here? CONH2. Okay. Here the question is Gabriel halamide synthesis. Here halamide is the starting reagent. So what is the reaction of halamide structure? First I write the reactions, then I write explanation. Okay. So this is the benzene, C double bond O, C double bond O, H. This is halamide. Okay. If this halamide reaction, halamide is treated with KOH, and we go now water molecule. Okay, so water molecule used here means here KOH means K plus OH minus. Here H is there. This H combined with this OH and H2O is equal. Then what happens? This H is replaced by this K. Okay, so same. This is the benzene, C double bond O, C double bond O, then K. Okay, so this means potassium, salt of halamide. The one is potassium salt of halamide. So this one is plus, this one is minus. Potassium salt it is. Potassium salt of this halamide. Okay. Next, this is treated with X. This one is treated with what? RX. This one is alkyl halide. Then which one will remove? KX. Okay. I'll continue the product here. Then this become C double bond O, C double bond O. Here N is there. K is replaced by R. Correct? Here Kx will remain. Correct? So then this is followed by NaOH and hydrolysis. Okay, students? This is followed by NaOH, that is aqueous solution of NaOH. Aqueous solution nothing but NaOH, so H2O. Then it will give C double bond O, Na, compound. Understand? If this compound separates out this one, then the remaining is R, that is RNH2. This will split up. NaOH is there. Correct? So, sorry, this one is ONA. This NaOH splits into what? NaO minus H plus. Correct? So this one gets attached here. This one breaks. O attached here. ONA. Remaining is this RNH. H is added here means RNH2. That is primary. Understand? So this is the reaction steps. What happens? First, the phthalimide are treated with KOH. Okay? Phthalimide and treatment with KOH gives potassium sulfur. So when it is followed by, and when the addition of alkyl halide takes place, then what happens? It forms this type of complex or an intermediate, followed by hydrolysis of this NaOH solution. Okay, alkaline hydrolysis is it, then you will get primary. Okay, so the statement you have to write here, that is phthalimide on treatment with what? KOH, that is potassium hydroxide, forms potassium salt of phthalimide. Potassium salt of phthalimide. Okay. Then addition of alkyl halide followed by alkaline hydrolysis. This one, alkaline hydrolysis gives primary amine. Gives primary. This is the explanation and this is the reaction. First, only the reaction occurs where? This is the bulkier group, only reaction occurs here only. NH changes to NK, NK changes to NR, NR changes to ONA. By breaking this bond, you will get primary. Okay? Only the reaction taking place here. So this is simply a bulkier group. Understand? It is simply a bulk group. Bulk means big. So reaction is not taking here in benzene ring in here. It is only taking place here. NH changes to NK, NK changes to NR, NR changes to this by the formation of this R. So this one is students. This is sodium halide. When I take sodium halide. Sodium halide. Understand? So this is our gradual phthalimide synthesis. Okay. So the last reaction is there, that is Hoffman bromamide degradation reaction. Okay. Case Hoffman bromide degradation reaction. Very important as I told you. Students, so here the reaction, first one is we are taking amine RC double bond O NH2 reacts with bromine water in presence of NaOH. Okay, so amines reacts with bromine water in presence of NaOH, that is Hoffman bromide degradation reaction. So then they form what? RNH2 compounds. RNH2 compounds. Here C is there, and they form Na2CO3 plus Na plus H2. Okay, this one is footnotes. So continuous fluoride students. Okay, RNH2 plus Na2CO3 plus NaBr plus H2O. Okay, that is the Hoffman bromide degradation reaction. Here you take ethanolic solution. This is the reaction. And the very important for this is amide, this is bromine water, that is aqueous solution, and this one is NaOH, that is alkaline, gives amine with the definition of Na2CO3 plus NaBr plus H2O. Okay, so here this is 2H2. Here if you want to write this, write amine on treatment with bromine water and alkaline solution. Bromine water and alkaline solution in presence of ethanolic solvents. Ethanolic solvent gives what? Amine. Only if you write this much students, you will get complete pass. So they may ask the question, explain Hoffman bromide reaction, degradation reaction with example, or simply they ask Hoffman bromide degradation reaction. If they ask this much, you write directly the general reaction and this explanation. If they ask along with the example, you just replace this R by CH3. You just replace that R by CH3 group, you will get Hoffman bromide degradation reaction with example. With example means if R is there, that is the general reaction. In place of R, any CH3, C2H5 or any benzene ring is there, then that is example. Okay, so this is all about the preparation of the amines. Okay, in the tomorrow's class, we will discuss about the basic structure, the physical properties of the amines.